Boyce-Codd normal form or BCNF. At first discuss to the Boyce-Codd normal form or BCNF, a quick recap of normalization. Normalization is the process of efficiently organizing data in a database. Normalized data must be in relational data structure. At first, a normalized table, atomicity achieved, first normal form, partial dependency removed, second normal form, transitive dependency removed, third normal form, and now BCNF, non-trivial dependency removed. Now, what is Boyce-Codd normal form? Boyce-Codd normal form BCNF is one of the form of database normalization. A database table is in BCNF if and only if there are no non-trivial functional dependency of attribute on anything other than a superset of a candidate key. BCNF is an advanced version of 3NF. It is stricter than 3NF and also known as 3.5NF. Now, what is the definition of BCNF? A relational schema R is considered to be Boyce-Codd normal form BCNF if every one of its dependency x arrow y, one of the following conditions hold true. The relation is in 3NF, x arrow y is a trivial functional dependency, that is, y is a subset of x is a superkey for schema R. Now, example of BCNF. We have a college enrollment table with column student ID, subject and professor. In the above table, one student can enroll for multiple subjects. For example, student with student ID S01 has opted for subject DBMS and Java. For each subject, a professor is assigned to the student, and there can be multiple professors teaching one subject like we have in for DBMS. Professor Istas and Arsaha both teaches DBMS. Now, what is the key field of this table? In the above table, student ID and subject together form a primary key because using student ID and subject we can find all the column of the table. One more important point to note here is one professor teaches only one subject, but one subject may have two different professors. So there is a dependency between subject and professor, where subject depend on the professor name. This table satisfies the first normal form because all the value are atomic. These tables also satisfy the second normal form because there is no partial dependency and there is no transitive dependency. Hence, the table is also satisfy the third normal form. But this table is not in Boyce-Codd normal form. Why this table is not in BCNF? In the table student enrollment, student ID subject form a primary key, which means subject column is a prime attribute, but there is one more dependency, professor arrow subject. And while subject is a prime attribute, but professor is a non-prime attribute, which is not allowed in BCNF. To make this relation satisfy BCNF, we will decompose this table into two tables, student table and professor table. Below the student table, in student table there is two fields, student ID field and PID or professor ID field. It shows that student ID S01 has two PID, P1 and P2, because student ID S01 opted two subjects, Java and DBMS, and there is a professor table which contain PID, professor and subject. Now, both relations satisfy the Boyce-Codd normal form because both the table functional dependency left side part is a key field, so it's both are satisfy the Boyce-Codd normal form.